Okay, so if we're going to have a look at the electrolysis of aqueous solutions, then the solutions we're looking at are dissolved in water because they're aqueous. And we know that water has the formula H2O, and this is a water molecule. And this water molecule will ionize, form ions, and it will split into H plus ions and OH minus ions. So we've seen this before when we've been looking at the work on acids. Okay, so the fact we've got it dissolved in water means that we'll have these two ions inside the solution as well. Just a reminder that the electrolysis setup, here's our DC electrical supply. Then we've got our two electrodes that are made from graphite. One of them is going to be the cathode, and the second one here is going to be the anode. If our electrolyte is going to be sodium chloride in my example, and it's aqueous, this means that I will have sodium ions in here from the ionic compound. I will have chloride ions from the ionic compound. Because it's aqueous, if I go back to this means it's dissolved in water, then I will also have these two ions. So I will have H plus ions and OH minus ions. So here now, inside my electrolyte, I've got four lots of ions moving around. Let's take a look at the cathode. So if I come back to this bit, here's my cathode. Now remember, the cathode is called the cathode because this is where the cations are attracted to. In our previous work we've been looking at, cations we know are the metal ions. And when they get there, these metal ions undergo a reduction reaction. So the cations undergo a reduction reaction. So for example, if we had a sodium chloride solution like we've just seen, this, if I just look at the cations first of all, we will get sodium from the sodium chloride is going to be the cation, and because it's aqueous we will get H plus from the water, H2O. So I will have two cations inside my solution. Now the question is, when they get to the cathode, because they're both going to migrate that way, which of these two is going to react first? Who's going to be the first one to go? Now to understand this, we have to look at the reactivity series. So let me just bring that into the camera view so you can see this, okay? And the reactivity series you can see here, I want to highlight two parts for you. First part is that here is hydrogen, way down here, so this is not very reactive material. And as you go up here, they get more reactive, and I'm working my way up, and here I get to sodium. So sodium is far more reactive than hydrogen. Okay, so sodium is more reactive than hydrogen. You need to remember that fact. We're going to come back to that in one moment. Okay, so who's going to react first? Well, we use reactivity series, as I said, to help us do this. What's going to happen is my sodium ion, when it gets to the cathode, it is going to pick up an electron to form sodium. My hydrogen is also going to pick up an electron to form H. Remember, H is diatomic, so it's H2. Therefore, I have two of those and two of those in order to make that equation work. Now the question is, who's going to go first? Because they're both going to gain electrons, we need to think about this reactivity. Hydrogen, because it's less reactive, it's easier to make this gain electrons. Less reactive, easier to react it. Sodium gets there to the cathode, and it's thinking, you know what, I'm really reactive and very reactive. I don't want this electron. I want to stay an ion. Therefore, I don't want to gain the electron and become sodium. So it says, I'm not going first. I'm not going to react first. The hydrogen reacts first because it is the least reactive. So at the cathode, it's always going to be the least reactive of the two ions that will react first, because we're forcing it to pick up an electron. Okay, and that's how we're going to work our way through this, and we'll come back to that a few times to really understand that information. Just to flash this back under here again, so you can see here that whenever we have a solution that contains hydrogen ions, any solution with these cations in, then it'll be the hydrogen that's going to react first, because that's going to be the least reactive. But if we have hydrogen ions with any of these ions in, for example copper ions, then the hydrogen is going to be more reactive and the copper will go first. So we just have to remember that hydrogen is not very active, all these metals are above it, but copper, hydrogen is more reactive than copper.